Hi students, in today's session I am going to explain you about simple cubic structure, body centered cubic structure and face centered cubic structure. These three structures are very important for the university and examinations point of view. So go through this information carefully, and if you are having any doubt, please comment me in the comment section. I will give you clarity for your doubts. Okay, please watch this video. In order to understand about simple cubic structure, let us consider one unit cell. First of all, we have to know unit cell. What is the meaning of unit cell? Unit cell is the smallest part of the entire crystal structure which is repeated three-dimensionally. The smallest part of the crystal structure is called as unit cell. Okay. So how can we measure dimensions of the unit cell? So unit cell can be measured by using length of the x-axis, length of the y-axis, length of the z-axis. So these length of the x, y and z-axis can be represented by using lattice parameters like small a is the length of the x-axis, small b is the length of the y-axis, c is the length of the z-axis. Okay, a, b, c are the length of the x, y and z-axis in the unit cell, and alpha, beta, gamma be the angles between the respective two axes. Okay, these two are commonly called as lattice parameter. Depending on the lattice parameter, we will classify crystal systems into 7 types. Already we discussed about these crystal systems in the previous session. Now, in order to explain about the simple cubic structure, first of all, students have to understand about the difference between the crystal structure and a crystal system. Depending on the dimensions of the unit cell, we have 7 types of crystal systems which are categorized into cubic crystal system, tetragonal, monoclinic and so on. Now, these structures are classified based on the atomic positions inside of the unit cell. Therefore, depending on the position of the atoms inside of the given unit cell, we are going to classify into basically 3 structures. Number 1 is known as simple cubic structure. This simple cubic structure can be represented by using primitive. Okay, in some people are representing in the form of a primitive, some are representing in the form of simple cubic structure. So whatever you can take. So simple cubic structure or primitive, both are similar. Okay. Now to know about simple cubic structure, first of all, consider one unit cell. Okay. Inside of this unit cell, so each and every, so I am going to represent the help of another color. Now go through this slide carefully. Now this is a one corner of the units. This is a one corner. Like this, in this unit cell, it has how many corners? It is a first corner, second corner, third corner, fourth corner, fifth corner, sixth corner, here seventh corner, and it is a eighth corner. So if you can take any one unit cell, each and every unit cell contains 8 corners. So at each and every corner of the unit cell, there we will observe one atom is occupied. Now at this unit cell, so at this corner, one atom present, here one atom present, so second atom, and this is a third atom, it is a fourth atom, fifth atom, sixth atom, seventh atom, and eighth atom. Therefore, so these 8 atoms are occupied at the 8 corners of the unit cell. So this is a diagram. You can understand this diagram in a clear way by using this bigger diagram. So first atom, second, third, fourth, fifth, sixth, seventh and eighth. Therefore, in this simple cubic structure, it contains 8 atoms. These 8 atoms are at the 8 corners of the unit cell. Therefore, in this simple cubic structure, how many atoms are present? There are 8 atoms are present in simple cubic structure. Okay, these atoms are exist on the edges of the side of the unit cell. So this is one side of the unit cell. On this side, at this one edge, one corner atom present. At the other edge, another corner atom present. Like this, you can take another side. This is another second side. On the second side, at one edge, one corner present. At other edge, one more atom present. Like this, you can take any side of this unit cell. On the edges of each and every side of the unit cell, 2 atoms are present. At one edge, one atom present. At another edge, another atom present. Like this, atoms are distributed uniformly throughout the unit cell. Now, in this unit cell, how all atoms are arranged? These atoms are arranged on the edges of the unit cell means it looks like this. Okay. So, in this simple cubic structure, let us go through the second diagram carefully. Now, this is a first corner atom. This corner atom is at one edge of the side of the unit cell, and this is the second corner atom. It is also available on the other corner of the this side. So, this is the arrangement of atoms on each and every side of the unit cell. These atoms are always in contact with each other. That means, this is a radius of the first corner atom, radius of the second corner atom. These two atoms are nearer to each other. From the definition point of view, these two atoms are neighbors to each other. So, if you can measure distance from the center of the first atom to center of the second atom, this distance can be represented by using nearest neighbor distance. It is represented by using A. So, you can take any side on this unit cell. You can observe similar pattern of the corner atoms. So, here also you can observe atomic distance is equal to A. Like this, wherever you can observe, each and every corner atom is having in contact with the other corner atom. So, you can observe nearest neighbor distance on any side is equal to A only. So, if you can observe, so distance from the center of the first atom to the center of the second atom, this is known as R. It is the other R. R plus R is equal to 2R. So, nearest neighbor distance in simple cubic structure A is equal to R plus R, that is equal to 2R. Now, from this equation, we are going to get R is equal to A divided by 2. So, in the case of simple cubic structure, atomic radii, you can be written as R is equal to A divided by 2. Okay. Now, you have to remember this point. In the case of simple cubic structure, atomic radius is equal to R is equal to A divided by 2. You note this point. Now, we have to calculate coordination number. Now, in order to note coordination number is defined as the number of atoms nearer and equidistant to any other atom. That number is known as coordination number. Now we have to calculate coordination number for the simple cubic structure. Go through this information carefully. This structure is very, very important for the examination point of view. Not only for the examination, if you understand this structure, it is very easy to understand about remaining two structures, that is body-centered cubic structure and face-centered cubic structure. Therefore, you have to go through this information carefully without skipping the video. Okay. Now, I am going to explain you about the coordination number. In order to calculate coordination number, so according to definition of coordination number, now you can take any one reference atom. For example, in this slide, now I am taking this corner atom as a reference point. Now, with respect to this atom, we have to calculate coordination number. Now, to get coordination number for this reference atom, now let us consider this reference. Now, from this reference atom to other corner atom, measure distance. These two atoms are neighbors. Then consider this reference atom and distance between these two atoms. It is also same distance A. So according to the definition, this atom is nearer to the reference atom. Number 1 is completed. Similarly, the same reference atom is nearer to the second reference atom. So second atom like this atom is nearer to the third corner atom, number 3. So first atom, second atom, third atom in the above. Now distance between these two also similar. This is equal to 1, 2, 3, 4. So in front of this unit cell, adjacent unit cell present. So that is the fifth atom, and back side of this reference atom, one more atom is present. Therefore, if we can take any one corner atom in this structure, for each and every corner atom, how many number of atoms are nearer and equidistant? 6. Therefore, coordination number for the simple cubic structure is 6. Now you can note down this point. Now we calculated coordination number for the simple cubic structure, that is 6. Next we have to calculate packing fraction. According to the definition of packing fraction, it is defined as the ratio of volume of all atoms in a unit cell to the total volume of the unit cell. That definition can be rewrite in the form of an equation, that is n into 4 by 3 pi r cube divided by a power 3. Now in this equation, n means total number of atoms after sharing, 4 by 3 is the volume of each atom. This atom is in the form of a sphere. Now we are writing in the form of volume of a sphere, that is equal to 4 divided by 3 pi r power 3. Now divided by a power 3. This structure related to the cubic structure. The case of cubic structure, length of x is equal to y is equal to z. So a is equal to a. So a into a, it will be written as a power 3. Now to get packing fraction of simple cubic structure, we have to find total number of atoms after sharing. Now to know about this total number of atoms after sharing, let us consider this structure. In this structure, now you observe this logic carefully. Now you can take this atom. This atom is, some part of the atom is in this unit cell. Remaining part is shared by the adjacent unit cells. Therefore, after now you can observe this point carefully. This atom is shared by the adjacent unit cells, 8 adjacent unit cells. So after sharing with the adjacent unit cell, the share of each atom becomes 1 divided by 8. Now you can take another corner atom like this. In this unit cell, total number of atoms are 8 atoms. And share of each corner atom is 1 divided by 8. Now this 8 and this 8 is going to calculate. Now we will get total number of atoms in simple cubic structure is equal to 1 only. Now in the case of packing fraction, now substitute n is equal to 1. Therefore packing fraction is equal to the place of n, substituting 1, the place of 4 by 3 into pi r power 3. We are using r is equal to a divided by 2. In this equation, 4 by 3 into pi, the place of r, we are substituting a divided by 2. Small correction is required. So in the place of r, we have to write here a. So here, 1 into 4 by 3 pi, a divided by 2 whole power 3. So here a power 3 and a power 3 is going to cancel. So after cancelling the a power 3 terms, now we calculate the remaining numerical. What we will get? 0.52 is a packing fraction of simple cubic structure. Generally, packing fraction is mentioned in the form of a percentage. Therefore, packing fraction of simple structure is equal to 52%. So, polonium is the only element which can exhibit simple cubic structure. It is about simple cubic structure. Now, we can recollect about the simple cubic structure. So, in simple cubic structure, 8 atoms are occupied at 8 corners of the unit cell. So, there exist 8 atoms in this unit cell. Now, these 8 atoms are occupied at the edges of the sides of the unit cell. Therefore, we can take any 2 corner atoms these atoms are in contact with each other. Because of this reason, we can get R is equal to A divided by 2. Now we have to calculate coordination number. According to definition, each and every corner atom is nearer and equidistant to the 6 other corner atom. Therefore, coordination number can be written as 6. Now the ultimate goal is to calculate packing fraction. Now we have to write equation for the packing fraction n into 4 by 3 pi r power 3 divided by a power 3. Now in this equation substitute n is equal to 1. N is equal to 1 we are going to get here. Now in the case of simple cubic structure, each and every corner atom is shared by the 8 adjacent unit cells. Therefore, the share of each corner atom becomes 1 divided by 8. Similar type of atoms are 8. So 1 divided by 8 into 8, that is equal to 1. So after sharing with the neighboring atoms, only one atom is present in this SEC structure. Now substitute n is equal to 1, r is equal to a divided by 2 and calculate this value, will get 0.52 or 52%. Example for the simple cubic structure is the polonium. This is about simple cubic structure. In the upcoming class, we will discuss about the body-centered cubic structure as well as faces-centered cubic structure. Okay, so all of you subscribe my channel for getting updates. Hit the bell icon in order to get the frequent updates. Thank you for watching.